they will give they will give integer array. So these array have random numbers. Okay, let's say 2, 9, 8, 4, 5, 1, and they will also provide a target equal to, let's say, 13. So what they will ask is, this is the input. Okay, so I'll write this down here, input, and output they will ask an integer array of indices of two numbers, which will create sum. If we add that two numbers values, it should be equal to this 13. For example, by looking in this array, so I'll write out indices for you. So 0, 1, 2, 3, 4, 5. These are the indices. So we just have to look out for a two number combination which adds up to this particular target. So in this case, that combination comes with this thing, or this thing also. 9 plus 4 is 13 and 8 plus 5 is 13. So any two numbers can come up with this combination which adds up to 13. So we can return whichever array possible. So 9 index is 1 and 4 index is 3. This can be the answer, and also 8 index is 2 and 5 index is 4. 2, 4 can also be the answer. But the main point is to return the indices of two numbers which adds up to this target value. Let's say, for example, if the target they have given a different value, let's say 9, they are saying the target is 9. So 8 plus 1 is 9. In this case, which we have only one combination, so answer is, for 9 the answer will be index 2 and index 5, because index 2 has value 8 plus index 5 has value 1, which equates to 9. So that is the problem statement. So the output should be, output data format should be int array, which contains indices. So yeah, I'll clean this out. So basically there are two approaches. We know this. Usually whenever we are writing a code, there are two approaches. One is brute force, another one is optimized approach. So whenever in an interview, usually interviewer asks a question like this. The first thought comes into our mind is this brute force approach. It is a conventional approach, like complexity will be greater in this brute force approach. But in optimized approach, the complexity will be optimal, means we will go to the extent in which we will optimize to greater level. So beyond that point we can't optimize. That is called optimized solution. So in brute force solution, what we will do is we'll create an int array initially, and we'll check. So we'll loop the array 2 times, so the complexity will be O of n square. So in this double looping, for loop inside another for loop, iteration inside iteration, so we will go and check for each and every combination. First we will take 2, check this 2 with all these numbers. Later on I'll take 9 and I'll check this 9 with all the numbers. I'll take 8, check with remaining all numbers, so on. I'll go like that. So for this particular thing, complexity is like this. In optimized approach, whatever we're gonna discuss in this video, so the complexity will be O of n. So how we are achieving this O of n optimized complexity? So the main helper in this particular optimized solution is hash map, because hash map have O of 1 complexity. For putting into the hash map, for fetching from the hash map, for storing and getting the values, hash map's complexity is O of n. As we are doing this for this particular array which is of size n, for this optimized complexity will be O of n. So that is the thing. So we'll see the pseudocode next. Later on we'll do the dry run for this example. Okay. So yeah, I'll write the pseudocode. So the first point what we'll be doing is, let us assume that these are the values given in the problem statement. Array is the array they have given and target is the target. So I'll write PC for you, which denotes a pseudocode. The first step what I'll do is int n. I'm getting the size of array dot length. That is the first one. Second step is I'll create a new hash map. Okay, map of integer comma integer. So usually whatever code I explain, it will be in the Java language, Java programming language. Mostly I'll follow that. So if you are trying to do it in remaining programming languages, basically the pseudocode is same for every language. The application will be changing from language to language. So map of int comma int, let's say hash map will be hm. I denote it with a variable hm. Map of integer comma integer, hm new hash map, and define it. So this hash map will be useful for storing value in the first integer and index in the second integer. So I'll denote v and I. V means value, I means index. I am storing in that format. The third step is I'll be writing a loop. So iterate array from 0 to n minus 1. From index 0 to n minus 1, I'll be iterating the array. It can be using for loop, mostly for loop we use. So going inside the loop, what I'll do, the first step I'll do is I'll check. Okay, the first step inside loop, I'll check. I'll write an if condition. If hm dot contains key of target minus array of I. So I will be the constant that we use to iterate. Means what we are checking exactly is in this hash map, let's say target is 13. 13 minus the first value is 2. 13 minus 2, 11. If 11 is already inside the hash map or not, that is what we are checking here. If it is already inside, means that we found the solution, because target equal to two numbers, right? Array of I plus already the thing which exists in the map value key. If two numbers are equating to target, then we have to return the solution. That is what we are doing. I send this into this array of I, particular iterative element to the left, so that if map having the value is equating to these two, target minus array of I, that is what I am doing here. So if that is the case, what I am doing will be return new int array of I comma hm dot get target minus array of I. So it may be confusing here. So what I am doing here is new int in the sense I am creating a new array to return. I means whatever index that we are currently in the iteration, and hm dot get of target minus array of I means target minus array of I is the value basically. So target minus array I is the key basically. So using this particular key, I am getting the value. So we have said here key means value, value means index. So let's say it is storing in this format. 9 is key and 1 is index is value. So this is key, this is value, like this. So we need index there, that means value in the map. So that's why we are getting it like this. And the second step is, in each and every iteration, definitely we don't have to forget and keep hm dot put array of I comma I. So this is a basic step here. So here what we are doing exactly is, in a map we are putting that particular array element and its index. That's what we are doing, because if we keep this in the map, then only we can track each and every element in the map. Means only if we put this in the map, we can be able to check this condition, I mean later in the next steps. So that is the thing. So right now the loop will be completing, inside steps will be completed. So let's say I didn't find any solution here in this entire, let's say some non-existent target I have given, let's say 90 I have given. So in this we have all small elements, even though you add any combination we don't get 90. So in that case what it will do, it will go through the entire loop once, entire array once, and it will come out. We didn't find any solution here. So what we will do at the time, we have to return empty array, new int of, just a simple empty array will be written. So that is what it is. The simple dry run we will do here is, I'll just write a hash map. I'll write a box for a map, okay, and I value, I'll denote it here, I value. So what will happen is, first the hash map is already created, we'll be starting the loop. Index is 0 initially. So whenever index is 0, the value is 2. So hm doesn't contain target minus 2. Target is 13, 13 minus 2. 13 minus 2 is 11. Hash map is initially empty. So this condition, we don't go inside the if block, directly we come out. So the first element is 2 and key is 2 and value is 0. That is the first mapping we keep. Second one is target minus 9. 13 minus 9 is 4. We don't have any 4 value here in the hash map. So directly we keep 4 is the key value and index value 1 is the value. Next one, 8. So 13 minus 8 is 5. We didn't have 5 inside this, but we have to keep 8 here and 2. Now 4. 13 minus 4 is 9. We didn't have 9 here, so we'll keep 4 and 3 is the index, its index value. Now coming to 5. 13 minus 5 is 8. 8 already exists. So this condition satisfies at that point. As 8 already exists, what it will keep? I, which means value 4 comma this index, because we found 8. 8's index is 2. 4 comma 2. If we can clearly observe, index 2 plus index 4, 8 plus 5 is equal to 13. Whichever answer we are targeting, means which is equal to target. So it is returning 4 comma 2 in this case. So that is the dry run example. Simply we will do hash map is the main thing which helps us to decrease the complexity and achieve the optimized solution. So do watch the videos for DSA. Thank you.